Hello class, welcome to Stat 1200. I am your instructor William Buellman. Today we are going to cover section 4.1, Basic Concepts of Probability. Our objectives for this section are to be able to construct sample spaces, compute and interpret probabilities, and approximate probabilities by using the empirical method. A probability experiment is one in which we do not know what any individual outcome will be, but we do know how a long series of repetitions will come out. For example, if we toss a fair coin, we do not know what the outcome of any single toss will be, but we do know the outcomes for a long series of tosses will be about half heads and about half tails. The probability of an event is the proportion of times that the event occurs over the long run. So for a fair coin, that is one that is equally likely to come up heads or tails, the probability of heads is 1/2 and the probability of tails is 1/2. The law of large numbers says that as a probability experiment is repeated again and again, the proportion of times that a given event occurs will approach its probability. So we see that down here in this graph, that as we're early off in our coin flips, here we're at like 3 coin flips, here we're at 5 tosses, you can see that the probability here of heads is 0.6. And it kind of bounces around until we get to about 100. Once we're at 100, we're pretty close to 0.5, and you can see how it goes under for a while, but as we get closer to 1,000, we're still about the same, and then by the time we get to about 10,000, if you see here, we're at 0.4994, so we're really close to 0.5, and that's what the law of large numbers says. The more times you do the experiment, the closer and closer you will get to the actual probability. The collection of all possible outcomes of a probability experiment is called a sample space. Here's our first example. Describe the sample space for each of the following. The toss of a fair coin. Well, it can either be heads or it can be tails. The roll of a 6-sided die, so it could be 1, could be 2, could be 3, could be 4, could be 5, or it could be 6. Selecting a student at random from a list of 10,000 students at a large university. The sample space is the 10,000 students, so the sample space consists of the 10,000 students. We are often concerned with occurrences that consist of several outcomes. For example, when rolling a die, we might be interested in the probability of rolling an odd number. Remember, odd numbers 1, 3, 5, 7, etc. Rolling an odd number corresponds to a collection of outcomes on a 6-sided die, which are 1, 3, and 5, from our sample space of 1, 2, 3, 4, 5, and 6. In general, a collection of outcomes of a sample space is called an event. Once we have a sample space, we need to specify a probability of each event. This is done with a probability model. We use the letter P, capital P, to denote probabilities. For example, we denote the probability that a tossed coin lands on heads by this right here, big P with heads in parentheses. In general, if A denotes an event, the probability of event A is denoted by P of A. Here are 3 rules to all probabilities. The probability of an event is always between 0 and 1. In other words, for any event, 0 is less than or equal to the probability of A, which is less than or equal to 1. If an event cannot happen, then the probability of that event A is equal to 0. If A is certain to happen, then the probability of A is equal to 1. Probabilities with equally likely outcomes. If a sample space has n equally likely outcomes and an event A has k outcomes, then the probability of A is equal to the number of outcomes in A divided by the number of outcomes in the sample space, which is equal to k over n. Here's our second example. In a lottery, a winning number between 0 and 999 is chosen at random, with all the possible numbers being equally likely. What is the probability that all three digits are the same? So all three digits being the same would be 0, 0, 0, 1, 1, 1, 2, 2, 2, etc. So again, the events that we're interested in are 0, 0, 0, 1, 1, 1, 2, 2, 2, all the way to 9, 9, 9. So if we count those, there are 10 of those in total that have all three digits the same number. So the probability all three digits the same is equal to the 10 outcomes where that is possible over the 1,000 total possible outcomes in the sample space, which is equal to 0.01. So sampling is a probability experiment. Sampling an individual from a population is a probability experiment. The population is the sample space, and the members of the population are equally likely outcomes. Here's example 3. There are 10,000 families in a certain town categorized as follows. 5,219 of those families own a house. 1,433 own a condo. 2,563 rent a house, and 785 rent an apartment. A pollster samples a single family from this population and wants to know the following two things. What is the probability that the sampled family owns a house? And what is the probability that the sample family rents? To remind you, there was 10,000 households, so the sample space consists of those 10,000 households. Of those, we want to know who owns a house. So the probability of owning a house is equal to the 5,219 people that owned a house over the 10,000 that were in our sample space, which gives us 0.5219. That is the probability that a randomly selected person will own a house. So now we have to figure out, for the second part, the number of families that rent. Well, if you remember, there was two sets of people who rent. People who rent houses and people who rent apartments. So we have to total that up first so we know how many total renters there are. So there was 785 that rented apartments and 2,563 that rented houses. So our total is 3,348 people that rent. So the probability that somebody rents is equal to that 3,348 over 10,000, which is equal to 0.3348. So our probability that somebody rents is 0.3348. An unusual event is one that is not likely to happen. In other words, an event whose probability is small. There are no hard and fast rules as to just how small a probability needs to be before an event is considered unusual, but we will use this rule of thumb. So our rule of thumb is going to be any event whose probability is less than 0.05 is going to be considered an unusual event. Here's example 4. In a college of 20,000 students, 423 are math majors. A student is selected at random and turns out to be a math major. Is this an unusual event? The event of choosing a math major consists of 423 students out of the 20,000. The probability of choosing this math major is 423 out of 20,000, which is approximately 0.0212. So since 0.0212 is less than 0.05, this is an unusual event. Approximating probabilities by the empirical method. The law of large numbers says that if we repeat a probability experiment a large number of times, then the proportion of times that a particular outcome occurs is likely to be close to the true probability. The empirical method consists of repeating an experiment a large number of times and using the proportion of times an outcome occurs to approximate the probability of the outcome. Here's example 5. In a recent year, there were 2,046,935 boys and 1,952,451 girls born in the United States. Approximate the probability that a newborn baby is a boy. First thing we're going to do is we need to figure out the total number of births there were. So there were 2,046,935 boys and 1,952,451 girls for a total of 3,999,386 births in total. The proportion of births that were boys is that 2,046,935 over the total number of births, 3,999,386, which is 0.5118. So we approximate the probability of having a boy is approximately 0.5118. which we know is fairly close to 50-50 as we expect.